So alternative to practical, we will solve today question 5 to question 7 from topic time period. So question 5, the class is investigating the motion of a pendulum. Figure 4.1 shows an apparatus. A mass is there which is attached with the spring and it will vibrate to and fro. That is the pendulum. Figure 4.1 shows on figure 4.1 show clearly the length of a pendulum. So if you want to, you can use chat, you can use mic or screen annotation. So what should be the length of a pendulum? If you have to mark that as L, what should be the length of the pendulum? Yeah. So length of a pendulum from a point where we hang till the center of the mass. That will be refers to the length of pendulum. So the position point where the object is hang till the center of the mass of an object is refers to a length of a pendulum. Then use figure 4.2 to explain how you could determine the length accurately as possible. And you may draw a diagram. And for reference, they provide that you have a set square and a meter rule or a meter scale is there. So what you can do, you should place a meter rule next to the pendulum or close to the pendulum. A meter rule should be placed. And there will be a set square to measure its length accurately as possible. So the points when you mention what you can mention place a meter rule or a meter rule close. So if you want to measure, so what you should do, you should always measure the like place a meter rule close to a pendulum and then set square use as a horizontal reference means to avoid a parallax error. So we will place a meter rule closer to pendulum and we will use set square to avoid parallax error or using a set square. So we will look horizontally like we can identify the exact position and measure the length. Is it clear, this one? Okay, the next one is the next question. A student determines the time t of a pendulum, like how much time it is taking to complete an oscillation, and he recorded a time for 20 oscillation. So time period for the time period is a time for one complete. The student record the time for 20 oscillations. So this is a figure 4.3 shows a time for 20 oscillation. Calculate the period, time for one oscillation. So what will the time period if 20 oscillations are is equals to 20.22? So we have the time for 20 oscillation, which is 20.22. And we want the time for one oscillation. So what we should do, 20.22 divided by 20. So it will be 1.011 seconds. But when you write your answer, you should always use a three significant figure. So we will just write as 1.01 seconds. So writing answer in three significant figure is the way whenever you write answer three or sometime two, but most of the time it is always three significant figure. Acceptable, even some cases it accepts 4 significant, but the thing is like better to be write all the answers as one, as 3 significant figures. Then explain how measuring a time for 20 oscillation rather than one oscillation help the student. Like if we measure a time for 20 oscillation, that will be more accurate as compared to that of one oscillation. How this will improve the results? So the idea is that because if we carry out, like if we measure a time for 20 oscillations, we'll have an average time. Yeah, like the judgment where start and reaction time can be reduced, reduce the effect of an error, like because it is spread over a 20 swings. If you are measuring a time for one swing, then what will happen? Likely will lead, it will you'll get an error. So idea is that you will get an average result when you measure a time for 20 oscillation. What we'll have an average result, because like we'll have more values out there. So the total time divided by number of oscillations, that is an average. Same thing, judgment or a reaction time is also minimized. Like it is, the error is spread over 20 swings. Otherwise, if only one swing is there, so that one swing will have an error. But now the same error is spread over 20 swings. So it reduces the percentage uncertainty. How it is an average, you can see instead of recording a time for one oscillation, you're recording a time for one oscillation is say 2 seconds. But what you did, you record the time for 20 oscillations. So that will be example, maybe 41 or 42, any number is there. Like when you measure a time for one, you're getting 2. But when you measure a time for 20 oscillations, you're getting 42. So what you will do, 42 divided by 20, so you will get an average, because average is the total divided by the number of calculation or number of values we took. So instead of taking for one swing directly, we took for 20 swings. So whenever such question is there, this will give an average result. And it reduces the percentage uncertainty in the results. Or you can also say reduce the reaction error due to reaction time. Is it clear, this one?
Yes, sir, clear.
Then you have to determine t square. So if the t was 1.01 second, what will the value for t square with the suitable unit? So if t is 1.02, what will the value of a t square with the suitable unit?
It will be 1.04 second square.
So it will be 1.02.
04.
04?
Sorry, mister. It's 1.01 or 1.02.
No, this one is 1.01.
This one is 1.0.
So, mister, it will be 1.02 second square.